Hi, now we are going to learn the hydrogen bonding. At the end of this lesson, students should be able to describe the hydrogen bonding. Then, relate the effect of hydrogen bonding on the following physical properties, which are the boiling points, the solubility, and the density of water. The hydrogen bonding can be defined as attractive forces between the positively charged of hydrogen atom of a molecule and the negatively charged of the electronegative atoms such as fluorine, oxygen, and nitrogen of another molecule. When hydrogen is bonded to a highly electronegative atom such as fluorine, oxygen, and nitrogen, the bonding electron pair is drawn towards the electronegative atoms. The nucleus of hydrogen atom is exposed to attraction by nearby electron cloud, which is a lone pair electrons on electronegative atoms. There are two essential requirements for formation of hydrogen bonds. First, a hydrogen atom must be directly bonded to a highly electronegative atoms. Second, the non-bonded electron pair electrons, or alone pairs, is represented by electronegative atoms. We can see the formation of hydrogen bonding between the HF molecules. There are also hydrogen bonding between the ammonia molecules. And the H2O molecules. The strength of hydrogen bonding determined by the interaction between the lone pair electrons of the electronegative atom and the nucleus of the hydrogen atom. There are two factors affecting the strength of hydrogen bonds. First, the number of hydrogen bonds formed, and second, the electronegativity of the atoms. Hydrogen bonding exerts a strong effect on physical properties of materials such as boiling point, solubility, and density. The compound that having hydrogen bonding show abnormally high melting point and boiling points. The high melting point and boiling points of a compound containing hydrogen bond is due to the fact that some extra energy is needed to break these bonds. Why do water molecules, ammonia, and hydrogen fluoride have abnormally high boiling point? A water molecule can form 4 hydrogen bonds with neighboring molecules. The ammonia can form 2 hydrogen bonds with its neighboring molecules, while the hydrogen fluoride molecule can form 2 hydrogen bonds with neighboring molecules. Water molecule can form more hydrogen bonds than ammonia and hydrogen fluoride. Thus, water has a stronger hydrogen bond than ammonia and hydrogen fluoride. By comparing the nitrogen and the fluorine atom is more electronegative than the nitrogen atoms. Thus, hydrogen fluoride form stronger hydrogen bonds than in ammonia. The boiling point of water is the highest and decrease to hydrogen fluoride to ammonia. Water is a good solvent for polar molecules that can form hydrogen bonds with water molecules. For example, ammonia is soluble in water because the ammonia molecules can form hydrogen bonds with water. Amines also soluble in water because the amino groups in amines can form hydrogen bond with water molecules. Alcohol and carboxylic acid are also soluble in water because the hydroxy group in the compounds can form hydrogen bond with water molecules. However, not all organic compounds that contains amino and hydroxy groups are soluble in water. As the relative molecular mass increases, the nonpolar hydrocarbon portion or the hydrophobic area will become larger. Since hydrocarbons are insoluble in water, the solubility decreases as the relative molecular mass of the organic compound increases. The hydrophobic is referred to the water-fearing, which is used to describe the nonpolar region of a molecule. And the hydrophilic is referred to the water-loving, which is used to describe the polar region of molecules. Water is unusual in its ability to form an extensive hydrogen bonding network. When cooled to a solid, the water molecules arrange themselves to form tetrahedral arrangement in such a way to maximize the amount of hydrogen bonding between them. Relatively large amount of space between them give rise to an open structure. This arrangement of molecules have a greater volume than a liquid water. Thus, water molecule expands when frozen. This open structure of the ice accounts for the fact that ice is less dense than water at 0 degrees Celsius. When ice melts, some of the hydrogen bonds are broken. This allows the water molecules to be compactly arranged, that resulting in 9% decrease in volume. When volume decreases, the density increases. Therefore, water has a higher density than ice. That's all for today. Thank you.